Hi friends, now we are starting one new lecture. Actually, if you want to join our classes, at first I will show. We also introduce one Google Classroom. Okay, in the Google Classroom there are machine learning, quiz competition, data structure, placement for the gate, deep learning, neural network, NLP, and DMS with coding, software engineering, cloud computing, blockchain, and design and analysis, and course file project. There are total number of 350 project, and C++, reasoning aptitude, predictive analysis, Python, complete course, advanced data structure, data science, data mining, artificial intelligence with coding and generative AI, IoT, digital logic gate, and DMS, DVMS, engineering, mathematics, computer network, computer architecture, operating system, complete computer designing, and flat finite automata, and grammar and Rust programming. So if you'll open this one, there are more than 10,000 codings are available. Okay, so in this video lecture, at last I will send the Google Classroom. You join the class, and after then check the link, and we uploaded already the collab files. You can open anytime. So today we will discuss the neural network. So deep learning, machine learning, everything is easy for you. Okay, so we will teach you the neural network plus maths. Okay, because what I observe, without maths and Python, it is very hard to understand the AI. Okay, so now the first one I will start with mathematics plus same, because Python has written according to the mathematics. We will start. Now you can see this is only one neuron. Okay, this is only one neuron. So these are the input 1, input 2, input 3, and one is bias. So this is one neuron and this is the output. I have written sigma of xi wi. What is the meaning of this? I am writing in Python x is equal to, suppose I am writing 1, 2 and 3. This is my list in Python. After then again another list I am writing, w is equal to, I am writing suppose 0.2 and this is 0.0 minus 0.5. This is my another list w. And bias I am writing suppose 2 because there is only one. And output I am writing, what is the output? Output is sigma of this. What is the meaning of this? I am writing x of 0, x of 0. Okay, according to the code, x of 0 into w of 0. Okay, so x0 and w0 plus, because of summation, after then x1 into w1 plus x means input, x2 into w2. Done. So at last I will add the bias. Done. So this is your output. Now at last you will write print output. So it will display the answer. I will show also later in your collab. Now the first question is coming, what is the time complexity? If suppose there is a total number of n element and here also n element, you can see 0, then 1, then 2. So this loop is working from 0 to n minus 1. So time complexity will be order of n to complete this code. I will tell one thing, time complexity is totally based on the number of input, number of weight, and number of layers. Later I will show. Okay, this is the first simple coding in neural network. Now the second question is coming. Later I will show the code also. I will run the code in Colab. Okay. Second question. Suppose there are many, suppose 1, 2, 3 and 4. Okay. And total number of neurons are 3. So if I am writing only one, x1, x2, x3, x4. Okay. So this is output 1, this is output 2, this is output 3. So 100% the weight will be associated. Okay, so now you can, I am not writing all. So this is W1, this is W2, this is W3, and this is W4. Actually this is not W1. According to mathematics or coding, this is not W1. What is this? This is actually 1 1. This is 1 2. This is 1 3. This is 1 4. Okay. Similarly, you will write for this one also. I am using this different color. This one, and this one. So we have done for one output. Now suppose there are many neuron. Neuron 1, neuron 2, neuron 3. Okay. So suppose there are many neuron. In this condition, how to write the code? I am writing simple mathematical, and later I will show you how to write in a loop method. Then after in NumPy. Okay. So first I am writing x is equal to, again x is equal to 1, 2, 3 and 4. These are the input. Then I am writing w is equal to 0.2, then 0.0 minus 0.5. You can write anything. And second I am writing, suppose 0.5, 0.9 suppose. Okay, and this is 0.20 and this is minus 0.5. Next I am writing, suppose minus 0.26, minus 0.27 and 0.17 and 0.07 suppose I am writing. And this list actually what is this? This is the list of list. Okay. Now I am writing bias. My bias is equal to 2, 3 and 0.5. Okay. Bias are 3. Okay. Now next output. What is the output now? See. What is the output? If such condition. Now see here, I will take this element 1, x0 into, I am writing w, okay. But here one problem. What is the problem? Directly I cannot access this one, or I can also write, I am writing, suppose w1 is equal to, you can also write, no problem, w1 is equal to, suppose I am writing w0, I am writing w2 is equal to w1, w3 is equal to w2. What is the meaning of this? Means the first list I associated with w1, second list I associated with w2, third list I associated with w3. Now I can write directly, O is equal to x means input, first element multiply the weight 1 means this, okay, and its first element means 0. Done. Similarly for other, x0 done, x1 2 into. Now next w, this is w1 because first element, and this is w0, this is w1, plus x means input 3, x3 into w weight 1 third element. What is the third element? 2. Done. Here we have written something wrong here. We should write one another weight. Okay. So now next plus x4 into, x4 means 4 into weight 1 means weight 1, this element 3. Done. Okay. Plus bias 0. Okay. This we have done for one neuron. Now this is only one neuron. Next neuron, similarly I will write next neuron for this one also, and for the, I am not writing everything. So what is going on here? Listen here. What I am writing, x, okay, this is 0, this is x0, this is x1 actually, x1, this is x2, this is x3, sorry, this is x0, x1, x2, x3, w0, w1, w2, w3. Okay, so 0 0, okay, see here, 0 0, 1 1, 2 2, 3 3. What is going on? X I, W J I. What is the meaning of J? Means first weight, then second weight, then third weight. Okay, so this J, and XI WI. So 0, then 1, then 2, then 3, summation. So what is the meaning of this? I is equal to going from 0 to suppose n, and again summation. Okay, J is equal to 0 to n. This is the, if I will show, if you are not able to understand, actually what we have done, we have written, I will show, x0 into w1, w1 1, x1 into w1 1, x2 into w1 2, x3 into w1 3 plus bias 0. Means for the first input we are multiplying xi into wi, okay, then x1 into w1, x2 into w2, x3 into w3. This one is associating this first list. After then w2, you can see w2, 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 w2. So this w2 is associating second list. So each element you are multiplying. So x0 means the first element you are multiplying this, then this element multiplying this, then this, then this, then this. Similarly for here w3 also. Okay, so what is going on? Actually this one. And if you will see, so what is the time complexity now you can measure. You are using 2 loop. Okay, so time complexity is order of n square overall. And if you want, suppose you want, I will show something. Later I will show in Colab also. And suppose you want, I will also show you the same code also. I will show. So what we have written here, for the, there are total number of 4 neurons. Okay, 4 neurons, input are 3 and 1 bias, and after then same code we have written, you can see. And what is the output? I will also show. What is the output? I will also show. Same thing also, if there are total number of 4 inputs are there. If there are total number of 4 inputs and weights are 4, 1 bias, then how to adding? How we are adding? Okay. I will send, later I will run the code in Colab. Now third one, suppose the inputs are like that. What we are doing actually? First input, second input, third input, fourth input, and you are, every input there is a weight you are associating with the first neuron. Second thing also for second neuron and third neuron. We made different colors. It is very easy to understand. Okay, and similarly we have also written the code. If you will check, similarly we have also written the code also. Later I will show in because here it is not possible to display. You can see. So now this is the complete code. Okay, there are total number of these weight, and we associated with W1, W2, W3, and bias 1, bias 2, bias 3, bias. Total number of 4 bias are there. Okay, and after then we are writing neuron 1. Okay, then neuron 2, then neuron 3, and at last we are printing the overall value. Okay, so if you will see, So I think that you understand. Now there is a question. What is the question is coming? The question is, there are total number of 4 neurons. Okay, and there are total number of there are total number of 4 inputs and 3 neurons. Okay, and suppose there are many inputs and many neurons, then how to solve this problem? Now I am writing one very beautiful code. Okay, I am writing one beautiful code, that is loop method. By the help of loop method also we can solve this problem. Same code, problem is same. What is the problem? There are total number of 1, 2, 3, 4 inputs are there, and there are total number of, I will show how many, total number of 3 neurons. Okay, and what I have written, x1, x2, x3, x4. Okay, now this is very important topic. So now what we are doing now, listen here. So at first we have to learn, number first, before coming this topic, at first we have to learn what is zip. Number first, what is zip? Okay, I am writing n is equal to, suppose, a comma b comma c, done. And I am writing, suppose age is equal to, I am writing one list, 10, 20, 30. This list I am writing. And I am printing, print, print list. I am writing zip. Okay, I am zipping what? This n and ag. Okay, 1, 2, 3. So what the output? The output will be the first one a. Okay, then its age is equal to 10. Then second b, its age is equal to 20. Then third c, and its age is equal to 30. This is your this. Now what is the meaning of this? At first we have written list. I want a list. Okay, done. I want to zip this and this. What is the meaning of zip? Means this associate, one mapping is there. This associated with this associate with this, and this associate with this. So A10, B20, B20, C30, C30. That is the meaning of zipping, one mapping. And suppose there are n plus 1 element and here n element, after then also it will never display, because there is only n element here, n plus 1 element. So the compiler will work only for this one. Means it will, suppose there are n element, there are n element, here are n minus 1 element. So the compiler will never work. It will work only for this one. Getting? What is the meaning of this? Suppose you have not written this one. So it will A associated with 10, B associated with 20. There is no data, nothing is there, nothing will happen. The meaning is this. Okay, I think that you understand. So time complexity is equal to order of n for the zip. Number first. Second, what I observe, many students, they don't know the Python. Without learning Python, they are using ChatGPT and directly they are solving the problems. Okay, today we are writing one another very important program. Okay, so the students, they are not able to understand. I am writing one code, looping method. I am writing something. I am writing. Okay, then you will understand actually what is this. Suppose I have written suppose x is equal to one list, and in the list I am writing 1.1, 2.2 and 3.3. I think that the texts are visible. Okay, then second I am writing another list, w is equal to, and there are 2, 0 and 0. List of list, this is the meaning is 2, 2, 0. And third I am writing 2, 2, 2. Done. Okay. Now I am writing bias. My bias is equal to suppose 0 0 1, suppose, and suppose my layer output is equal to suppose initially I initialize, nothing is there. Now I am writing for I am writing my, this is very important, my neuron weight comma neuron bias in zip, okay, W comma B, number first. This is very important. What is the meaning of this? What is the meaning of this? This is very important. I will explain. Next, I am writing inside neuron output is equal to initially let 0. Then again inside the for loop, again I am writing another for loop. Sorry, another for, because I have a habit of C. So sometimes neuron input, I am writing here W. Why? I will explain why I am writing here W. In zip, and I am writing X means input, my input, and I am zipping W and B means weight and bias. Okay, I am zipping here X and neuron weight, this neuron weight. What is this actually? Why I am writing here? Second Y. Done. Now I am writing inside, I am writing neuron output is equal to plus is equal to, means neuron output is equal to neuron output plus neuron output is equal to 0. Neuron input into W. What is the meaning of this? This meaning sigma of Wi Xi. This is the meaning. Okay. Now after then I am writing neuron output plus is equal to neuron bias. I am adding. What is the meaning of this? Whatever the value sigma Xi, and I am adding the bias. Okay. Bias of J you can write. Okay. Done. At last I am writing layer output. This layer output is equal to, means append, layer output. I am appending A P P E N D, append neuron output I am writing. Okay, and at last I am printing layer output. What is this? I will explain. Now see, I have written this one. Number first I have written, this is my list, this is my list, this is my list, this is my list. Now I initialize one empty list. I am writing for NW, means weight and bias. My weight is this, bias, my weight and bias, my weight and bias are these. So I am zipping. What is the meaning of this? Now see here, if you are able to listen. Now see what is going on here. So this is my what I have written, my neuron input and weight, my neuron input and weight. Okay, I am zipping X and NW. So what is the meaning of X? Okay, I am zipping, sorry, the first one is this, my neuron and weight, neuron weight and neuron bias. I am zipping W and B. I am zipping W and B. So now this is my neuron bias, my neuron bias. Okay, so first my neuron bias is 0 0 1. I am writing 0 0 1, 0, this is 0 and this is 0 and this is 1. You can see 0 0 1. Getting? So 0 0 1. So this associated with this weight. What is the meaning of list of list? The first W1, W2, W3. List of list. The first list, second list, third list. First list, second list, third list. Means this bias associated with this list. This bias associated with this list. This bias associated with this list. Meaning is this. Done. I can also use different color. This and this, and this and this, and this and this. Getting? So associated with this one. Okay. Everyone associated with this one. Okay. Now next I am writing neuron input. Okay, this is another one. Comma W. This is very important. W. I am zipping X and NW. X means input. Input is, this is your input 1 1, another input 2 2, another input 3 3. So this is neuron input, neuron input, neuron input. Okay, you can see. So this input associated with this one, what? This 2 0 0. This is the list of first list. Okay, wait. List of first list. Neuron weight, neuron weight. Okay, neuron weight, this neuron weight. So this neuron weight first associated with this one. Okay, but I have written here W. This is very important. After then I am writing W here. Actually, what is this? This is very important. Okay, so both are associated. Okay, after then what is going on? I will show you. In the neuron W, when you are writing W, okay, W is associated, first W is associated with this 2 0 0. Okay, so now you are writing neuron input. So your neuron input is first element, first element associated with this one. Okay, W. Then after then this loop is working from 1 to n, means it's means total number of element in my input. Okay, so this 1.1 into this one, now you can see I have written here. So 1.1 into this, 2.2 into this, and 3.2 into this. First weight. So I have written here, you can see. Easily you can understand. W1 means first weight, first element multiply with first input. Done. Weight 1, second element multiply with second input. Weight 1, third element multiply with third element. Okay, first element multiply with first element, second element multiply with second element, third element multiply with third element. So this is weight 1, weight 1, weight 1, weight 1. Getting? Similarly for weight 2, weight 2, weight 2, weight 3, weight 3, weight 3. Same we have written. So you should remember why we are writing this W. And this is NW, means at first we are zipping these two, and then after then we are zipping these two. So overall time complexity is order of n square. There are total number of 2 for loop. This is very important to understand the time complexity. Without learning the time complexity, impossible to understand. And if you are still not able to understand, you can see x1, x2, x3. They are associated with this associated with this associated with this one. Okay, easily you can understand. So one loop it will work, then after then this loop will work, then third this loop will work. These are two. So this is very important, how this zip is working and how it is associating and how it is working. Okay, this is very important. So append means after then all you are appending backside. Okay, I think that you understand. This is the first loop method. Now at first I will show the code in Colab. Okay, then after then I will run the code. Then next we will discuss about the NumPy and how to write the same code in shortcut method. Okay, so we already saw the code. Again, this is the complete course of neural network. So in the first program what we saw, total number of inputs are 3, x1, x2, x3, and weights are 3, 1 bias. Then what we are doing, summation of xi, wi. Okay, time complexity is order of n. You can see this code already we explained. Now next, the second one, suppose there are total number of inputs are 4 and weights are 4 and bias is 1. In this condition also similar answer, sigma of wi xi plus bias. Okay, so x is the input, w is the weight, b means bias. Okay, o means output. Okay, so now this is very simple question, and suppose there are multi layers are there, means there are many neurons. So same process you have to apply multiple time. Okay, first neuron same method, second neuron same method, third neuron. So I have written w1, w2, w3, then w11, w21, w31. Okay, so similarly you can see that this is a very long process if the neurons are more. What is the problem? We have to write multiple times. For the neuron 1 again we have to copy and paste multiple times, we have to write the code. This is very complicated. So to remove this complexity, what we have done, we have find one easier method. It's the loop method. In the loop method, what we are doing, x is equal to 1, 2, 3, 2.5. These are the inputs, and weights are, this is a n into n matrix. So the first list is introducing W1, second list is introducing W2, and third list is W3. There are total number of 3 lists. Bias is 2, 3 and 0.5. Okay, 3 bias are there. And layer output is initially, you initialize null. And after then I am writing for NW means neuron weight, and comma NB means neuron bias in ZIP. Already we explained what is the meaning of this. W means weight, B means bias. And inside you are writing neuron output is equal to 0 initially. Then one another loop for neuron input, comma W means weight. So you have to understand this weight. This is very important. In ZIP, x comma neuron weight. So after then you are adding summation. Actually what is this? Summation of xi wi plus n. So you are using total number of 2 loops are here. So time complexity is order of n square. You can check also. Okay. Now we will discuss about the NumPy. Okay. By the help of NumPy, how we can reduce more and more. How we can write the program in 8 line, the overall program. Okay, neural network overall program we can write in 8 line or 10 line, maximum 10 lines. We will explain, at first we will explain the NumPy, then we will explain the what is the meaning of transpose, what is the meaning of matrix, and the NumPy method, and suppose there is a dense layer, and what is the meaning of training data set, something one by one we will explain. Back propagation and the forward pass, loss, everything we will explain. Okay. So now students, now we will discuss about the NumPy. Okay, this is used for the neural network and for the scientific purpose actually. Okay, now we are using here dot product. Now how it is working? Suppose you have A is equal to list 1, 2, 3. Okay, so we are using this one. Suppose your list is equal to, your list is 1, 2, 3. Your list is 1, 2, 3, and total row is 1 and column is equal to 3. Same also now you have another B matrix 3 into 3. This one. Okay, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is a 3 into 3 matrix. Now how it will work? You will write np dot b comma a. Okay, this is dot product. So how it is working? B, your B is 4, 5, 6, 7, 8, 9, 3 into 3 matrix, and 1, 2, 3. What is 1, 2, 3? 1, 2 is 3 is this. So but you have to write the transpose here. Okay, this is the main thing, you have to write the transpose, this transpose. Okay, without the transpose it will not work. So transpose means 1, 2, 3. Now you can multiply these two matrices. How the matrix is multiplying? Your first column, your first row will multiply this column. Okay, so 4 into 1, 4 into 1, 5 into 2, and 6 into 3. Okay, so similarly you have to multiply this and this also. Okay, for this and this also. So you are getting this one, you will plus, and at last you are getting this, the value is equal to 32, 41, 68. So this is the matrix multiplication. Now we will see np dot a comma b. So before what we have written np dot b comma a we have written. Now what we are writing? We are writing np dot a comma b. So a is 1, 2, 3 means 1 into 3, first row 3 column, and b is 4, 5, this is 3 into 3 matrix. So now we can multiply. After multiply, my output will be 1 into 3 means 1 row 3. There is a there are 3 row 1 column. We should write 3 row 1 column. Okay, so now after multiply, I will multiply. How I will multiply? I will multiply. Okay, I am writing this one.
I will multiply this row to this column. Okay, this row to this column. So 1 into 4, 2 into 7, 1 into 4, and 2 into 7, and 10 into 3. You will multiply, you will add, you will get 48, 54, and 60. Okay, so now what we can see, we can see so dot product of a comma b is not equal to dot product of b comma a. Okay, so this is not possible. You also know that two matrices are not equal. Now what we will do, we will come here. Suppose in my program I have written x is a list. Okay, I have written x is a list. And this is the input. Okay, x1, x2, x3. You can write any value. And weight, I have written w in my program. Weight is equal to w1, w2, w3. And my bias is only one. B1. Okay, this is my bias. I am writing output. In place of output, I am writing O. O is equal to np dot w comma x plus b. So how it is working? This is working like this. x1 into w1 plus x2 into w2 plus x3 into w3 plus bias. So this is how the dot product working in my neural network. Now I will show another example. Suppose I have this structure and I have total number of 4 input x1, x2, x3 and x4. There are 4 inputs. Now my output is one output, second output and third output. So according to the output I will get some weight. I got one this weight. This is w11, w12, w13 and w14. Okay, this is for output 1. Now what I will write? So x1 into w1, x2 into w2, x3 into w13 and x4 into w14 plus bias is equal to the output. This is my final. Okay, so now here bunch of weight for every output. What is the meaning of this? There are many output. Okay, one output is this one output is this one output is this one. Okay, this is the weight one. So weight w11, 12, 13, 14 for output 1. According to the output I have written here w11, w12, w13 and w14. Okay, this is for output 1, weight 1. Similarly there are 4 output for weight output 2 and there are 4 output and 4 output 3. Okay, so we represent w1, w2, w3. Okay, in our coding. And my inputs are x1, x2, x3, x4. My bias also b1, b2, b3. So our bias and weights, it's depend on the output. What is the output? My outputs are this. So now at last what we are writing? We are writing np dot w comma x plus b. Okay, this is the final outcome. And similarly you can write np dot x comma wt plus bias. Already we have seen. So both are equal. So how it is working? It is working like this: np dot w1 comma x plus bias. Okay, np dot w2 comma x plus bias and np dot w3 comma x plus bias. So this is the output number 1. What is this? This is the output 1, this is the output 2 and this is the output 3. Okay, so output 1, output 2, output 3. Getting? So now I think that you understand. Now I am taking one very simple example. Up to this we have taken only output is actually input is x1, x2, x3, x4. Okay, suppose there are bunch of inputs are there. Okay, suppose there is a bunch of inputs. I am writing suppose there is a bunch of inputs. My inputs are x is equal to 1, 2, 3. This is the first 1, 2, 3, 2.5. So this is batch number 1. And 2, 5, minus 1, 2.0. This is batch number 2. And minus 1.5, 2.2, 2.3, 0.0. This is batch number 3. Okay. And before this x1 representing the overall column 1, this x2 is representing this column, and x3 is representing this column, and x4 is representing this column. So this is overall 3 row 4 columns matrix for the input. So batch 1, batch 2, batch 3, I am representing B1, B2, B3. Okay, so now what I will do, I will come here. Now second, if there are many bunch of inputs, weights are also there. So weights are let W1, W2 and W3. Okay, so means what is the meaning of this W1, W2, W3? It means that my structure, I will show later structure. So this is the weight also according to this 0.2, 0.0, minus 0.51, and first this is the weight number 1 and 0.5 minus 9.0 and 0.26 minus 0.5, this is the weight number 2, minus 0.26 minus 0.27, 0.17, 0.87, this is the weight number 3. So what we are doing, this is the W11, okay, this column, this is W12 second column, W13 third column, W14 fourth column. So for the batch, there are total number of 3 batch are there. It means that there are total number of 3 outputs. Okay, so this code is also similar. This code is also similar. 1 minute. This code is also similar. Means for this structure we are writing this code. Means there are only 3 output and only 1 layer. Okay, so now I will come here. So for the batch, how it is working? For the batch, B1 dot W1, B1 dot W2 and B1 dot W3. Okay, and similarly B2 for the batch 2 W1, batch 2 W2, batch 3 W3. Similarly for this one also. Okay, so if you understand this line, what line? The line is this. This is the main one. So for batch 1, what we are doing, x1 into W1, what we are doing, x1 into W1 plus x2 into W2 12 plus x3 into W13 and plus x4 into W14. Means what is this? This is actually what we are doing. We are this overall x, okay, this is only batch 1, overall x we multiply with W1. This is W1 overall, this is W1 in my program. This is the batch 1, okay, and this is the W1. Now similarly this is the batch 1, it will work for this one. So here also many weights are here, 1 2 3 4. Okay, similarly also here also many different weights are here. Okay, weights are 1 2 3 4. So this yellow weight, it is representing W3, and this weight it is representing W2, and its weight it is representing W1. We can also written here W1, W2 and W3. Okay, so same also this is also working here. If you will see what we are doing in this bunch of file, what we are doing, same process we are applying here. Okay, same process we are applying here, B1 W1, B2 W2. Okay, how it is working, this is very important. Now in the program directly you are writing np dot x comma wt. Okay, means W transpose. Okay, no need to understand, but for the mathematical, if you are a good coder, then it is very important to understand how they have written the code, so you can analyze the time complexity. Okay, now your final output, what will be your final output? Your final output will be output is equal to np dot x comma np dot array. Now there is a question, what is the need of array? I will explain. And w means at first you will convert this w to array, then it's a transpose plus b. So this is the final output. If you will multiply, you will get this output. Okay, here we are not explaining. Now another one, suppose there are many layers. Up to this we add multiple batches, multiple inputs are there. Now suppose there are multiple layers. in this condition how to solve this problem. So what we are doing, our inputs are x1, x2, x3, x4. Okay, this time only one batch. Okay, and there is this is the hidden layer 1, and this is the hidden layer 2. What is this actually going on? We are taking x1 into w11 and after then w12, w13 and w14. x1 into w11 and x2 into w12 we are multiplying, and after then I will get one output. So this output will be the input for this new output for the next layer. I will tell you how. Now see here. So what we are doing, np dot, up to this we understand, up to this np dot x comma w1t plus b1. Okay, up to this. Now the output is f1. Okay, now see here in the hidden layer what is going on. Whatever the output you got by the help of this, you got one output here. Okay, so this output is f1. This will be the input for this next the next output, means for the next layer. So now suppose this is output is f1. So this f1 I will write now for the next output. I will write here f1 comma w2t. Okay, so for the next layer also there are many w, means weight will come. Okay, so and plus b. So we got the second output. Similarly we can get all the output 1, output 2, output 3, output n. Okay, now we will try to teach you by the help of one simple example. Suppose there are many bunch of inputs are there. So this is the 1.0, 2.0 and 3.0, 2.5. This is the batch number 1, and bunch of input 2.0, 5.0, minus 1.0, 2.0. This is the batch number 2, and minus 1.5, 2.7, 3.3 and 0. This is the batch number 3. So there are many 3 bunch of input. Similarly there are weights are there. Okay, w1, w2, w3 already we discussed. Okay, after then similarly there are total number of 3 outputs. So weights are bias are 2.0, 3.0 and 0.5. Now what I will do, at first I will convert my this x means input to array. Okay, because convert list to array, you have to understand. Before it was the list, you have to convert to array, otherwise it is very hard to find the transpose. Okay, so now I am writing np dot array input. I am converting input to array and I am giving one name, that is ia, and I am converting my weight to array, then I am giving one name w underscore a. This is the new name. Similarly for my bias, this is the new name, b underscore a. At last I will get the output. My output is equal to np dot my input is equal to x, but I convert in array, and this is my weight, updated weight, I convert in array, and it's a transpose, and at last this is my bias. Very simple. You have to learn only this sigma xi wi plus b, only this formula. Okay, sigma xi wi plus b. So this is how the forward pass is working. Now suppose there are 2 layers. This is a very simple example. So how it is working now, see here. This is the first x1, x2, x3, x4, and this is the second layer in inputs. Okay, whatever the output you will get, this is the input, okay, for the next layer, and this is the final output. Okay, so there are 2 layers. So weight 11, 12, 13, 14. I will get one output. This output will be the input for the next layer. Okay, and weight will come like this. Okay, weight also will come like this, w21, w22, w23, and final output I will get. So every time I am using this same formula. What I am doing, at first I will convert my array, my input to array, my weight I will convert to array, my bias I will convert to array, and similarly there are different weights also for the second layer, W21, W21, W12, W13, you can see. Okay, so similarly I will also convert my this weight also to array, and this bias also will array, because there is also one bias, and there is also one bias will come, there is also one bias will come. Okay, so what is the meaning of this? The output by the help of sigma xi wi, this output will be the input for the next layer. Okay, so what is this? My L1 underscore O, this is the output. Okay, np dot my this x means input, comma weight, it's a transpose plus b. So this is my layer 1 this output. So this output will come here, where this output will be the input for my next layer. Okay, so that is the meaning of forward pass. Okay, L1 underscore O, and weight, new weight will come, and bias similar. At last you will print the output. So what is the meaning of forward pass? Forward pass means whatever task you have done, sigma xi wi, so whatever the output is coming, this output will be the input for the next layer. So I will get another output. Okay, this is the meaning of forward pass. Okay, now I will come
now in this code. Okay, here I have written W2 and B2. Okay, but because of the lack of space, I have not written what is W2 and what is this B2. So our request, either you can initialize the W2 also as well as B2 also after then, or you can write also this W and W2 both are same, or you can write this B and B2 both are same. Okay, either change this one W and W2 again initialize, I initialize, same thing also B2, something random number you can write. Okay, or you can write W and W2 both are same and B and B2 both are same, nothing will happen. So this is for the multi-layer. Now the question is how to solve if the layers are dense. Okay, so we will start the class now. Okay, so before go to the dense class, this is very important to learn about the spiral data. Okay, because randomly we are taking many batches, many inputs. Now you have to import this one nnfs dot dataset. From nnfs dot dataset, import spiral data, import numpy as np, because this time we are working in np, import nnfs. Okay, so in nnfs dot init, now I will explain what is this. Import matplot, because you are plotting, dot pyplot as plt. Now we are taking x and y. What is x? Total samples are 100 and classes are 3. Okay, there are 3 different classes I will show in my program. One is red, second is green, third is blue. Okay, 3 classes are there, and total samples we are taking for the input 100 x and y. Now plt dot scatter, so we are plotting the graph, so scatter, then we are showing the data. You can also write the code, and I will also show how, after running the code also. Now we will discuss about the what is this, what is the meaning of this in class. Now this is the we will learn about init. Okay, so this init is the method, or you can say this is the constructor. Okay, so this we are using to access the specific instance. Here we have written class teacher, and we created def means a function. Okay, method self, what object just you created, so it will access here name, and these are the arguments subject. So self dot name is equal to name, self dot subject is equal to subject. Another function, so we are taking just self, whatever the instance you created, print self dot name, the name will print here, teaches that this is the text, self dot subject, this subject will display here. Now T means object. T means object. By the help of class I am giving Yogesh name and computer science. So this name is the Yogesh and this subject is the computer science. So directly it will access and after that it will print here. So this is the meaning of this method INIT. Okay, this is very important to learn about the dense class. So now we will discuss another topic. This is one thing is very important. I will show. What is
another one? Before coming here in the code, at first I will come here. Where? Okay, now we understand up to this. Okay, we understand. Now see here. Suppose I have actually we have written one program, and the program based on this this structure. So there are total number of two input actually, x1 and x2. Okay, but I have written bunch of input. Means what is this? And there are 100 row and 2 columns are there. Okay, 100 row and 2 columns are there. Means what is the meaning of this? Inputs are only 2. Okay, but randomly I am taking multiples data. Randomly I am taking multiples data from here. Okay, later I will explain. Okay, so one by one it is coming. Okay, so now this is my first output, this is my second output, this is my third output. So what I am doing, x1 into w11 and x2 into this one. Okay, then I will get my output plus bias, plus bias. Similarly plus bias. Similarly for this output also what I will do, for this output also x1 into w12 and x2 into w22 and I will get one output plus bias, and similarly for this also, and x1 into w13 and x2 into w23 and plus bias is equal to I will get third output. So there are three different outputs are there. My three different output 1, output 2, output 3. Okay, so now see how it is working. I will come here. So output will be what is my matrix? My matrix, how the matrix is working I will show. So my inputs are x1, x2. My inputs are x1, x2. My weight is this one. My weight is this one. I will multiply this to this one. Okay, how I will multiply? I will multiply this row to this column. Okay, so x1, you can see x1 w11 plus x2 w12. Okay, one output I will get. Again I will multiply this to this. Okay, so x1 w21 plus x2 w22. Again I will multiply x12 to this column. Okay, so x1 w13 and x2 w32. Okay, and plus bias. So this is my forward pass, this is my final formula, mathematical formula. What is the formula? Summation of xi wi plus b. This is my final output. My output will be like this: x1 w1 plus b, one output, second output, third output. I think that you understand, already we explained here. So this is how the code is working. Now I will come here. My code, what we did in my code, already we explain, we teach you what is the meaning of numpy. Okay, so at first I am calling the numpy. Okay, then this line already I explained to, we are importing NNFS. So there is a data set. So randomly you can take 100 column. Okay, 100 row and 2 columns. There are 100 total number of 100 row and 2 columns are there. I can take many also, no problem. Here I am taking the data set from there. Okay, so I am taking the spiral data set from NNFS. Now there are two types of methods we have taken in the class, and what we are doing here, we are taking the sample weight. we are taking the sample weight. At first I will come here. So what is the meaning of this method? My function def forward pass self. I already explained what is the meaning of self. So self dot output is equal to np dot x comma self dot w plus self dot b. So what is the meaning of this? The meaning of this is equal to this one. This is the forward pass. Forward means sigma xi wi plus b, and how to write in class like this. Done. Now next I am coming here. Create data set. Already we explained. You create data set x and y. Okay. I am calling a spiral. Okay. Total samples are 100 and classes are 3. Okay. We want 3 classes. Total samples are 100. Now for the dense one. So layer dense 2 row and 3 column. What is the meaning of this? There are 2 row and 3 columns. 2 row and 3 columns. There are 2 row and 3 columns. Dense one. This is the layer number 1. 2 row and 3 columns. So we are calling the dense layer. So what is the dense layer? So dense layer is this one. Okay. Dense layer is this one. So what is the meaning of this? The meaning is whenever we are calling the dense layer, okay, whenever we are calling the dense layer, it will take the sample weights randomly. We are taking random weights and RA and DM. What is the meaning of this? We are taking the data according to the Gaussian distribution. Okay. So bias also randomly we are taking 0, and we have taken the weight. Okay. After then we are using the forward pass, and after then we are printing the value. Okay. This is a very small program. Okay. For this only one, if there is only one layer only. If there is only one layer. Okay, this program will work only for the one layer. If there are multiple layers, we will explain later. Okay, but we are taking bunch of many inputs. I think that you understand. Now I will come to my program. If you will see our programs, already we explained. Same program we have written. We are using the forward pass at first, then we are creating the data set. Okay, we are creating the data set, and here we have used the forward pass. Then we are using the layer, there is only one layer. Okay, and we are using the forward pass. Then we are taking the output, but from 0 to 5. Okay, so you can see there are some outputs are there. Now we will discuss about the ReLU function and what is the need of ReLU function and what is the need of softmax. We will discuss later. Okay, thank you so much.
Now this is very important, and this is our guarantee. If you are attending our lecture, you will become expert in neural network, deep learning, machine learning, in every subject. Okay, in this AI world. Now suppose we have given A is equal to, this is 3 into 3 matrix, 1 2 3 4 5 6 7 8 9. You can also write same in Python also. Our request, we are writing everything according to the Python. Okay. Now I am writing np dot sum of A. What is the meaning of this? It will summation of A, meaning it will sum everything whatever is there. It will add all element, that is 45. You can also check. If you run this code, you will get 45. Now suppose you are writing np dot sum A, okay, matrix axis is equal to none. If I am writing this one, means nothing will happen, again summation of A is equal to 45. But if you are writing axis is equal to 1, what will happen? What is the meaning of this? Axis is 1 and axis is 0 and axis is 1. What is the meaning of this? The meaning of axis is equal to 0 is, what is the meaning of this? 1 2 3, okay, plus 4 5 6 plus 7 8 9. Okay, so what you are doing? You are adding everything. At last you will get 12, and if you will add 12, 7 8 9 10 11 12, and this is 16, and this is 18, I think that. Okay, so this is dimension is 3. Okay, so you are adding row. Okay, and if you are doing this one, x is equal to 1, what is the meaning of this? You are adding 147 plus 258 plus 369. Okay, you are adding. What is the answer? Your answer will be 6, 3, 4, 5, 6, 6 and 15 and 24. Okay, your answer will be this. This is also 3. Okay, now what is the problem? I will show. Done. I am just erasing this one. I think that you can also write the same thing and you can check answer. Now suppose you are writing this one. So in the above we have written 3. Okay, so but we are not keeping dimension. What is the problem if you are not writing this keeping dimension? Keep dimension is equal to true, keep dimension is equal to true for both first and second. Okay, if you are writing keep dimension, what will happen? It will show this same value 12, 15 and the next value was 12, 16, I think that. Okay, before you can check 16 and 18. Okay, this was the sum. So this is dimension. It will take the dimension first row and 3 column. I will show late what is the meaning of this. And here also it will keep the dimension. The first one was 6 and second one was 15 and third one was 24 if you add. So dimension is 3 into 1. It is keeping dimension. What is the meaning of this? I will explain later. Okay, if you are writing this one, so every time you should write like that. Why? I will show you later. Now we will discuss about the broadcasting rule. Okay, so the broadcasting rule, we will discuss about the broadcasting rule. So broadcasting rule, we are discussing about this one. Okay, suppose you are writing np dot, you are writing x comma weight transpose plus your bias. Suppose this matrix is 3 into 3 and suppose just not leave it. Suppose there is a 3 into 3 matrix. Okay, this one 3 into 3 matrix and this is suppose 3 into 1. 3 into 1 matrix. Okay, so you can multiply but you cannot add both. 3 into 3 matrix plus 3 into 1 matrix. What is the meaning of this? You have a matrix 3 into 3. Done. 3 into 3 matrix. Okay, and you are adding plus 3 row 1 column. 1 2 3. 3 row 1 column. Can you add this one? Impossible. This is impossible. According to mathematics it is impossible, but how in Python? How in Python we are learning. So keep dimension is very important. I will show, because this is impossible. So broadcasting rule is applicable when rule number 1. Suppose there is a 3 into 3 matrix and another one is 3 into 1 matrix. If something is similar, second I am writing 3 into 3, 1 into 3. Something is similar. Okay, so either this or this or this or this, anyone is similar. Okay, then the broadcasting rule will work. If you are writing 3 into 3 one matrix and you are writing here 1 into 2, so the broadcasting rule will never work. This is impossible. So now what is the meaning of broadcasting rule? I will show. Suppose you have this matrix, same matrix, and suppose I want to add this 1 2 3 bias here. Okay, I want to add, and this is 3 row 1 column. Okay, how to add? So what the Python is doing, it is taking 1 2 3 4 5 6 7 8 9 and after then it is repeating this one 1 1 1 2 2 2 3 3 3. Okay, now you add, you will get answer. Okay, so this is broadcastable. Why? Because these two are same. 3 into 3, 3 into 1. These two are same. This is broadcastable. So after then it is your Python is working like this. Okay, and similarly suppose you have same matrix, this matrix है ना, A, and you are multiplying another matrix, this is 1 2 3, okay, and this is 1 into 3, this is also broadcastable. Okay, so either you are taking like that or like that, you are multiplying also, that is also broadcastable. So now we will discuss another one, something I am writing, this is very important. Now listen here, suppose your matrix is this, okay, and suppose I am writing A minus np dot max A comma axis is equal to 1. Suppose I am writing, okay, before the old method I am writing A means matrix, np, your np means numpy, I am taking maximum, okay, A and axis is equal to 1. Okay, now what is this actually? Your matrix is 1 2 3 4 5 6 7 8 9, this is your matrix, done, minus I am taking axis is equal to 1. Already I explained axis is equal to 1. What is the meaning of this? So axis is equal to 1. Okay, you are taking axis is equal to 1, and suppose this A is 3 into 3 matrix, okay, and this A I am taking maximum. So what is maximum? Maximum is 3. Okay, I am taking 3. I am taking maximum is 3. I am taking maximum is 3. Maximum is 3. Okay, and here maximum is equal to 6, and here maximum is equal to 9. And suppose you want to subtract A minus np dot max. Okay, so how the compiler will work? Your Python, it will take 1 2 3 4 5 6 7 8 9. Okay, then minus. So according to this axis is equal to 1, what he will do? He will write this 3 6 9 3. If you will see just old method, it will take this one. Axis is equal to 1 means a column. Okay, so it will work like that. And if you will check what is the answer, your answer will be wrong, because 1 minus 3 is equal to minus 2, and 2 minus 6 is equal to minus 2 minus 6 is equal to minus 4, and 3 minus 9 is equal to minus 6. Okay, similarly here. Now this is wrong. Why this is wrong? If you are taking, this is wrong. Actually what is this? I will explain. So now why it is wrong, I will show you. Because actually what we want A minus maximum. Okay, so this is your matrix, and you want to subtract a maximum from A. So what is the meaning of this? What is the max? Max is 3. So 1 minus 3, 2 minus 3, 3 minus 3, and maximum is equal to 6, 4 minus 6, 5 minus 6, 6 minus 6, and maximum is equal to 9, 7 minus 9, 8 minus 9, 9 minus 9. Okay, so what is the answer? Your answer will be minus 2 minus 1 0, and minus 2 minus 1 0, and minus 2 minus 1 0. This is your answer, but this answer is wrong, because the problem is you are not taking dimension. Okay, so because of you are not taking dimension, so this is wrong. So how to solve this problem? You have to keep dimension. Okay, this is the problem. So what you will write? You will write A minus np dot max A comma axis is equal to 1. Okay, then keep dimension dim. You can also write same time dimension is equal to true. Okay, you can write also the code in your Python also. Okay, so your dimension, if you are keeping dimension, what is the meaning of this? Your 3, okay, and 6, okay, and 9, you are keeping dimension, so 3 into 1. Now how the program is working? Your 1 2 3 4 5 6 7 8 9, this is your matrix, minus what you are doing? 3, 3, 3. It will write 3 times, 3 times, 3 times. Now multiply. Now subtract. So you can see 1 minus 3 is equal to minus 2. 2 minus 3 is equal to minus 1. And 3 minus 3 is equal to 0. Similarly also here. Okay, now you got the correct answer. So this is very important to learn this one, broadcasting. Okay, so if you are not writing this one, you will get wrong answer. So this is very important whenever you are writing any code in your program. Okay, now we will discuss about the something is very important. Still we are not discussing about the function. Okay, activation function. So there are many activation function we will not discuss. We are writing this time only one activation function, that is the meaning of ReLU, and second activation function sigmoid, and third is linear. Linear you already know, y is equal to x, and this is y is equal to 1 plus 1 plus e to the power minus x, and ReLU is equal to y is equal to maximum of 0 and x. This is very important function, activation function. Okay, so later we will discuss sigmoid and linear. Okay, this is sometimes it is also useful, sometimes it is also useful, but this time we are discussing about this one ReLU. Now actually what we will do in our code now, this time we will use activation function. Okay, this ReLU, this is the graph of this ReLU. ReLU is the non-linear. This is your ReLU. Okay, ReLU is the non-linear. This is because at 0 it is changing the direction. You can see straight line, it will never bend. Straight line never bend. It is bending. Bending means non-linear. So if you are using this ReLU multiple times, infinite times, okay, so after then it can cover also such type of graph also. If you are using, because bending is there, okay, if you are using multiple times this ReLU, then it can also overlap, it can also cover this such type of non-linearity. Okay, so this is the reason we are using ReLU in our activation function. Okay, so this is the non-linear. Okay, you have to remember this. Also came in GATE exam also. Okay, so this is very important. Now we are discussing another topic, softmax. Okay, so softmax is also very important. What is the meaning of softmax? I am writing something now here. Now actually we are writing something here. Actually suppose your output is equal to suppose 5, and second output is equal to 10, and third output is equal to 15. So what he is doing, he is writing e to the power 5 upon summation of all, e to the power 5 plus e to the power 10 plus e to the power 15. Same thing also here, e to the power 10 upon e to the power 5 plus e to the power 10 plus e to the power 15. Same thing also here, e to the power 15 upon e to the power 5 plus e to the power 10 plus e to the power 15. So if you will see the value, always the output will come 0 to 1. This is the very beauty of this softmax. Okay, so if you will add, everything will be 1. Now I am writing something. Suppose you have a matrix. I am just removing this one. Suppose you have a matrix. What is the matrix? Your matrix is, suppose this one, 1 2 3 and 4 5 6 7 8 9. Same matrix. Suppose your matrix, this matrix is A is equal to this, and how your function is working? Your function is working like this: e to the power 1 upon e to the power 1 plus e to the power 2 plus e to the power 3, e to the power 2 upon e to the power 1 plus e to the power 2 plus e to the power 3, e to the power 3 upon e to the power 1 plus e to the power 2 plus e to the power 3. Similarly for other. Okay, now suppose we have x is equal to, suppose I am writing one code, 1 2 3 2.5. There are inputs, these are the inputs, and second I am writing 2 5 and minus 1 and 2. Okay, and third I am writing minus 1.5 2.7 3.3 and 0.5, suppose something. Now how to write this one? So I am writing this EV, one variable name. This is np dot exp means exponential, x minus means input minus np dot max maximum. Okay, so x comma axis is equal to 1. What I told at that time, you are taking column and you have to take also keep dimension. Keep dimension is equal to true. Then it will work, otherwise it will not work. So this is the reason it is very important to learn each and every step. Otherwise you will get wrong answer. Okay. So now once you got this task, once you got, and after then you are writing probability. What is the meaning of probability? EV upon NP dot sum of all. Sum of EV, whatever the value. And again you will write axis is equal to 1 and dimension also keep dimension is equal to true. Every time you have to write, otherwise you will get wrong answer. Now print the probability. Your probability will print and this is the overall answer. Okay, so this is a way to write the code. If you are skipping something, what is the meaning of keep dimension? You are not writing axis, you are not writing, so your answer will never correct. You have to understand each and every step in your code. If you want, I will also show same program I have written. If you are you can see also the first one, activation function. What we are doing, we are importing numpy as np. Okay, my inputs are something. Okay, if you are not able to understand, I will show like this. Okay, so my numpy as np, then after then inputs are something. Okay, output is equal to np dot max 0 comma inputs, so you will get output. This is, we are using the activation function ReLU. So ReLU is taking the maximum. Okay, now next, ReLU activation by the help of class. I have written class activation ReLU. Then I am using the DEF forward self dot comma inputs self dot output is equal to. So this and this both are same, है ना? So this and this is by the help of class and this is by the help of simple method. Okay. So now the third one, if you want to create data set by the help of spiral, already we explained. Okay, so spiral, it is taking total number of samples is equal to 100 and classes are 3, and dense one, layer dot dense. What we are writing, layer dot dense 2 input and 3 layers. Then this dense, I got dense. Okay, then activation, I am using this activation function in this output. Then dense, I am using the forward x comma wt. Okay, forward pass already I explained. Then I am using the activation function output and I am printing the value. Okay, same thing also activation function for softmax. Just I explain you this code, already explain what is the meaning of axis, keep dimension, and if you are not taking axis is equal to 0, what is the meaning of axis is equal to 1, what is the meaning of keeping dimension. Okay, so you can also check. Now next one, this code already we have written. Suppose your input is this, and if you want to find the softmax, so how to use this one, np dot exponential, then you will write the probability and you will print the probabilities. Okay, so it will print the probabilities. Now softmax activation function by the help of class. Okay, you are using forward pass, already I explained. Okay, so you are using exponential, then you are using probability, then you are printing the value. Okay, now one forward pass without loss. This is very important. Now we will explain this one. Now up to this what we have done, I will show something. I am writing something. So what we have done, this is your input 1 and this is your input 2. Okay, Then after then what we are doing, this, okay, then this, then this, then this, then this, then this, okay, this is only. So this is, and after then again suppose I am using this another one, and this and this and this, okay, what we have done up to this. So this is my output, output, output. So this is my output 1, output 2, output 3. What we did, up to this I am taking the input, okay. So this is my layer 1, okay. I am using here ReLU. Now I am using here ReLU, okay, for the non-linearity, okay. This is my layer 2, okay. I am using ReLU, but at last here I have to use softmax. Why to use softmax at last? For the classification. You know that this softmax, it will take the output only between 0 to 1. So in which class my data? Either in 0 or 1. So by the help of this output, the output is some value. So we cannot predict the correct output. Okay, what is the output we don't know, because this is the value. So if the value are between 0 to 1, then we can find how much accuracy in my data, my output, and my output belongs to which category. Okay, so we are using softmax at last. This is very important. Okay, so what we are doing, we are using layer dense, then we are using ReLU, then again we are using layer dense in my program, layer dense, then we are using softmax, and at last we are getting the output result. Okay, so here what we are doing here, layer dense, we are using class, and inputs and layer. Okay, so what is the meaning of x comma w plus beta? This we are doing. Okay, next here in ReLU we are using another class. It will take max from 0 to x. Okay, then again we are using another layer dense in my program by the help of this method init. Okay, and again x w plus beta. Whenever I am using layer dense, the meaning is this. Whenever I am using layer dense, the meaning is this. Same already we explained multiple times. What is the meaning of softmax? We are using e to the power x upon sigma e to the power x. Okay, xi you can write. Okay, this is the meaning of softmax. Now I am writing one code and I will try to explain, okay, how the code is working. Now I am writing one code. Okay, so now already we explained the spiral data. We are taking total number of 100 samples and 3 classes. Okay, this line we already explained. So now what we are doing, dense 1 is equal to layer dense 2 comma 3. What is the meaning of this? We are taking 2 input and 3 output. The meaning is this. Okay, we are taking 2 input and 3 output. So x comma w plus this, meaning of this one. Okay, whenever you are using the layer dense, already explained just before. Okay, now next we are taking the activation function ReLU. After then, at first I am taking xw comma x dot w plus beta. Okay, then I am using a ReLU function. Okay, so I am using ReLU function I created. Okay, then after then I am using dense 2 is equal to layer dense 3 comma 3. Okay, this time I am using 3 input and 3 output. Again I am writing dense 1. In the dense 1 I am using the forward pass. Okay, in the dense 1 I am using the forward pass. What is the meaning of this? This is the meaning of x dot w1 plus beta. This is the meaning of this. Okay, then activation 1. What is the activation 1? This dot forward pass. I am using dense 1 and output. Okay, so what is the meaning of this? The output of 1 will be applied for the ReLU. Okay, means the output of the meaning of this one, the output of 1 will apply for ReLU, because activation, we are using the activation function. Here we are creating the activation function. Here we create, then we are applying activation function in the output of first dance. Okay, after using the forward pass in dance 1, I am applying here. Okay, I am using the ReLU function. Then after then I am writing dance 2 dot forward, same also dance 2 dot forward. So whatever the output came from here after applying the ReLU function, I am using again forward pass. Forward means again I will told this is x comma x dot w2 plus beta. Okay, another weight will come after then plus beta means here bias. Okay, I am using this one. Okay, again after applying this, again I will use my activation function. Okay, activation 2 dot forward I am using in the whatever the output from there. Okay, I am using dance 2. Okay, so this I am using here. Okay, the output I am applying here, the second activation function. Okay, and at last I am printing the 5 output from there. Okay, if you see, we have written clearly everything. Okay, if you want, sorry, we have written clearly. We will also send the code also in the first line. Act spiral data set, it is visual, see. Okay, so I think that now it is visual. So x y, then after then dance 1 layer activation function, then dance 2 activation function, then we are using the forward pass, then activation function we are applying to the ReLU, then again we are using the forward pass, then after then activation function, and at last got the result. So what is going on? Already we draw the figure. What we are doing? We are using, again this is a graph, layer dense, then we are using ReLU, then we are using layer dense, then again we are using another softmax, suppose we are using. You can use anyone. Okay, so we are using layer dense, then we are applying the ReLU, then again layer dense, we are using another activation function. So after this x dot w plus beta, okay, after then we are using ReLU, then we are using another layer, again same. So whatever the output, then after then x dot w1 plus beta, again we are using. So multiple times you can use. Okay, so this already we explained. Okay, so now the time has come, we will discuss about the entropy actually. What is the meaning of entropy? So we will discuss about the entropy. This is very important. Up to this we are not using the entropy. Now we are using the entropy. What is the meaning of entropy? Maybe there is a loss. Okay, what is the meaning of loss? So categorical loss, we are just talking about the CATEGORICAL, categorical loss, we are talking about this one. So now suppose you have two input x1 and x2, suppose, and there is something, and you got output is equal to 0.7, here you got output is equal to 0.1, here output is equal to 0.2. This is your output, and suppose our real, what we want actually, the first one, what is the meaning of, what is the difference between machine learning and programming? Number first, in machine learning we know the output, in programming we don't know the output whenever we are writing any code. So output already I know here 100. Now I am checking whatever the output I got, it is how much it is correct, I am checking. Okay, so how to check? I am using one method, minus sigma true value into log of predicted value. Okay, this method I am using. The first question, why I am taking minus? First question, why I am taking minus? Because the value, if you will see the graph of log, the log graph, that is actually like this. Okay, the log graph. So this is 0 and this is 1. At 1, log 1 is equal to 0. Log 1 is equal to 0. Okay, log 1, you can see log 1 is equal to 0. So whenever we are increasing the log, where increasing the log, it is converging to infinite. You can see infinite. This is y-axis, this is x-axis. It is going to infinite. Okay. If you are increasing the x, then it is going to infinite. Okay. This is wrong, I think that. Sorry for that. This is between 0 and 1. Okay. What is the log function? Log 0 is equal to 1. Log 0, log 1 is equal to 0. Sorry. Log 1 is equal to 0. Na? So what is the meaning of log? Log, suppose you have log 1000 and base is equal to 10. So this is 3. Okay. So what is the meaning of this? If you are increasing the log, then it is going to infinite. So if you will see the log, so what we want to say, if you will see the graph, this is suppose 1, like this. Okay. So actually log is not defined between this. Okay. Log is not defined between this one. So log 1 is equal to 0. Log 2 is equal to something. Log, if you are going to infinite, log is also going to infinite. Okay. Now, what about in between? What about in between? Log 1. What about in between? Okay, this is the question. So now we are just, so because of this, we are taking minus. So minus into minus is equal to plus. I think that you understand. We will not discuss if you know already mathematics. So now we are just going to here. Now suppose your predicted value is this, this and this. Now I am taking minus 1 into, this is 1 into my predicted, my true value, and log of 0.7 and plus 0 into log of 0.1 plus 0 into log of 0.2. Okay, what is the answer? Now you can see here already 0, already 0, my true value into log of predicted value, true value, predicted value, true value, predicted value, true value, predicted value. True value is this, predicted is this, what I got. This is my prediction, output is my prediction. Okay. So now you can see why I will concentrate here. If my focus is here, if I want output is red, this is red, blue, green, suppose, है ना? If my output, my focus is here, why I will calculate? So I will try to reduce the space complexity. Okay, I will remove these two. How? I will explain. So if you check, the answer will be minus log of 0.7, that is 0.3566. This is answer is this. So loss is low here. Loss low when you are converging to 1, when you are converging, and suppose there is another value, suppose the output is not like this. Output is, suppose your output is 0.5 and 0.1. output can be anything. In this condition, my output, this is 0, 0. Okay, I am taking only 1. Why I will take more? So 1 into log of 0.5. If you will calculate this value, after calculation you will get 0.69. Now you can see your loss is very high. Loss is high because it is very low. Okay. So whenever the outcome is converging to 0, your loss will high. Whenever your output is converging to 1, your loss is very low. What is our task? We have to reduce the loss. How? By the help of updating my weight and bias. How? We will discuss. Okay, I think that you understand. Now suppose you have this one. Suppose you have this matrix. Suppose you have this matrix, soft max output. Okay, is equal to suppose 0.7 and 0.1, 0.2, and this is 0.1, 0.5 and 0.4, and this is 0.02, this is 0.9, this is 0.8, suppose. Okay, and according to the dimension, keep dimension I have written. Okay, now suppose your output is 0, 1, 1. 1. This is the output. Means what is the meaning of this? This is 0 means red, this is green, and this is green. Okay. Now what we are doing? I am writing something. I am writing soft max output. Soft max output. I am writing 0 1 2. I am writing 0 1 2 comma class target. What I am writing? 0 1 and 1. I am writing this line. I am writing in my code. Suppose what is the meaning of this? The meaning of this 0 1 2 in my matrix A. The row are 0 1 and 2. 0 1 and 2. Okay. From 0 1 and 2, focus at 0. Okay, I will focus here. Focus at 1. Okay, I will focus here. Focus at 1. I will focus here. Done. This is 0 1 2. 0 1 2. 0 1 2. The meaning is this. So after then what will you get? You will get 0.7. This is the first value, and second value 0.5, and third value 0.9. By the help of this I reduce the space complexity in my code, because my target is 0 1 1. My target is this. First is red, green, blue. I want red. Red is 0.7. Green is 0.5. Green is 0.9. So my focus is here. Why I will focus other? Why? What is the need? So to reduce the space complexity, I did this one. But you should also note class target. What is the time complexity of this class target? You are focusing 0, 1 and 1. You are going to overall matrix. Okay. You are keeping one by one. You are going overall matrix. The time complexity will be order of n square. Okay. If you check, this is the time complexity of this one. Okay. So now up to this we discuss everything. Now suppose you have another one. You have two matrix, and suppose you have this matrix. Suppose you have this matrix. Your output is just like that. Suppose your output is 1 0 0 and 0 1 0 and 0 1 0. Output is in matrix form. In this condition you will multiply this matrix and this matrix. 0.7, 0.1, 0.2. This is your matrix, and 0.1, 0.5, 0.4, and this is 0.2, 0.9, 0.8. What is this? This is the predicted output, and this is your actual output. Okay. What you will do? I want this. Okay. I want this. Okay. I want this. I will multiply both matrix. By the help of this, my correct answer will be 0.7. Other are 0, 0, 0.5, 0, 0, 0.9, 0. My correct answer is this. Okay, and at last I will take the max value 0.7, 0.5, 0.9. By the help of this max I will get the max value, and at last I will take log and mean. I will find mean. Done. This is very simple code. Okay, so what we are doing, we are multiplying time complexity order of n cube. Okay, whenever the matrix, it's totally depend on the output is in which form. Okay. If your output in this form, in this condition, time complexity is increasing. So the machine learning, deep learning, neural network, it is totally based on the output. Now next one another important topic is, you can also see, suppose in any case there is a 0 is coming or 1 is coming. This is the biggest problem in machine learning or deep learning neural network. So we are trying to, there should be no 0 or no 1 in my predicted. Okay, so I will prevent from 0 and 1. How to prevent? I will use one clip method. Okay, by the help of this, the predicted value, I am using 1 dot e to the power minus 7, okay, comma 1 minus 1 dot e to the power minus 7, this method. So whatever the value is coming, okay, so after then I am preventing from 0, I am preventing from 1. Okay, one method we are using, okay, in my code. So this is the meaning of optimization. Optimize means to minimize the loss and to select the best weight and bias. Then we will discuss about the chain method. Okay, the partial derivative, the chain method. Okay, we will discuss the back propagation. We will discuss. So up to this, what we explain, we already sent the code in. Okay, we already sent the code in. Okay, softmax. Okay, I will show like this. Okay, up to this we explain. Okay, after then we are using the softmax. Okay, we are using the softmax. So cross entropy loss function. Okay, how the loss function is working. Up to this we explain. Okay, and then we are using this log method. Okay, softmax function. Okay, this already we explained. Okay, next we are using the we have taken one array and we are taking this one, the same question. Okay, what we are doing here, same, we are multiplying this and this. So my predicted value is 0.7, 0.5 and 0.9. Okay, so why I will focus other. So this is my correct answer and this is my predicted answer. Okay, after then I am getting this one. Okay, this is the method to write the code. And implementing the loss function by class also. This is also very simple. Already we explained. Okay, how the class is working. Now next, categorical loss for the cross entropy class. If you already know the previous code, then this is very easy to understand how it is working, the clip method. Okay, so now, so we will not discuss, we will not waste your time. Softmax we also explain. Okay, categorical loss, and then this is the overall code. Okay, whatever we explain up to this is the overall code with loss. Okay, I think that you understand. Okay, this is the overall. So now next, another topic is what is the meaning of accuracy. Do you know what is the meaning of accuracy? Accuracy means whatever the output is there, your output is 0.7, 0.2, 0.1. Accuracy means how close you are. How means, suppose you are actually, what is the accuracy means? I will show. Many people, they have confusion. Suppose you have a matrix. Okay, you have a matrix and your output is 0.7, 0.2, 0.1, and your output is 0.1, 0.5, 0.4, and your output is 0.02, 0.9 and 0.08. Your matrix is this. Okay, so in this matrix, the output, suppose the output is 0.7 and 0.5 and 0.9. Okay, so whatever the output you got, this output is max from here. Okay, this output is max from here. The output is max from here. So the output is how much accuracy? Accuracy does not means how much close you are to the target. Okay, what is the meaning of accuracy? Accuracy is different. Okay, you have to learn. Here we also try to explain actually what is the meaning of accuracy. The code we will show you. And we have also sent, we attach the Google Drive. There are more than 10,000 codes are there. Okay, so accuracy, how to find the accuracy. Optimization also means to reduce the loss. Okay, now this we will not explain. Now we will directly go to the back propagation now. Okay, the next lecture will be for the back propagation.